Hello folks, welcome to SigNoz Launch Week. Today we have with us Ankit, CTO at SigNoz, and he will be talking about how we have built the best solution for temporal observability in the industry today. Welcome Ankit, thanks for joining us. How are you doing today?
Hello everyone. I'm doing good. Thank you for asking. What about you?
Yeah, good as well. So yeah, I think would love to understand more on uh, why we chose temporal to work on and why what was it interesting. But even before that, let's give our audience a brief on what is temporal and like why is it important, what problem it is solving.
All right. So Temporal was requested by many of our customers and open source users. So I dived into what Temporal is, and interestingly, I learned a lot about asynchronous workflows and the problems associated with it. Like your application needs to handle the retry mechanism. You need to store the states where your application might fail. So all these problems associated with asynchronous system, Temporal handles them really well. And interestingly, I am very much fascinated by the technology that they have built, the Temporal server, and they also gave SDKs so that the developers can seamlessly integrate the concepts of Temporal, like client, workers, and tasks, into their application. And that's actually a very useful thing for us and for the community. Yeah, so that's the interest where we started to look into temporal, and then we looked into how we can bring up better observability and what more can be done for debugging temporal and understanding temporal.
Got it. So just to give people context, so temporal is a cloud service. You can also run it as open source, which essentially manages workflows and gives you durable workflows. So
Right.
if you think about it, for example, you have some workers, you have some tasks which you want to execute, and then you want workers to pick it up and then go and execute it. You need to, if you, for example, use a typical queue like Kafka, you will just like create this workers, create this task, and then the workers will pick up. But you still need to do the whole orchestration behind it. And as Ankit, I understand this is temporal, like goes much deeper, and then in the application code itself, you specify, hey, like this is the worker, this is the activity, and this is how you handle it. Is
Right,
that
Pranay.
sort of a correct description?
Right. You got a pretty good idea about on the temporal. Like it happens like that. Think of it as a workflow. Workflow is a combination of steps that you need to execute in order to complete the workflow, right? So I have a workflow, let's say, about processing my orders, right? So the step one is that order is placed. Step two would be I would go and check into the inventory if the order exists or not. Step three would be start shipping the order. Step four would be send a notification to the customer. Step five would be to run a reconciliation whether if the inventory is not available, then in the middle maybe you would want to refund to the customer and things of those sorts, right? So these we can call it as steps in the in a workflow, which a temporal can use its SDKs and the temporal service to beautifully orchestrate it and make it durable. It means like if step one to step two even takes minutes, hours, or days,
Mhm.
temporal is going to like persist the state of the execution of that step, and then it is going to ask your application to resume from where it failed or where it stopped. Right. So that's a fantastic piece about temporal.
Got it. So why is temporal observability important? If you are an application developer, why would you need observability for temporal workflows? And and yeah, like guide us, like help us understand why is observability important for us.
Sure, Pranay. So, like, observability in general is very useful to get deeper insights into what you have written out or coded, right? So, here, when your SDKs are using temporal service, your application and the debuggers or the developers need to know where did my workflow stop, how much time did my workflow take end to end, where which are the activities are the slowest one in my workflow. I would like to get a breakdown by task queue, activity type, or even namespace, which is a logical concept in temporal. So these are the few things that a developer will want to know apart from the logs, the usual logs that they emit in their applications that is custom to the application, right? So they would like to know about these and would like to get alerted on these metrics, so that like even the auto scaling logic of workers can depend on the latency of the schedule to start latency, which is a metric emitted by the SDK, where if you can see like it is being scheduled, but it is not being picked up by the worker, right? So it means there is some workers are overloaded, maybe one of the reasons. So you can set up auto scaling mechanisms based on these metrics.
Got it. Makes sense. And as I understand, Temporal also provides you some dashboards and analytics on how those workers are doing or how those activities are doing. Uh, so what we built, how is that different from what is there already in Temporal, or like what new use cases can it solve?
Right. So Temporal gives you an observability dashboard where you can filter by a few attributes in Temporal. Like you can filter by duration type, you can filter by every namespace you can see, you can even filter by activity type. But it is a list of events that happened, and you can even check the filter by duration. But it does not give you, like, it asks you to have your own SDK metrics so that your applications can tell, like, this is how much time I took to connect to the temporal service. This is the latency that an application is observing, and not just the server latencies, right? Apart from that, all the custom logs that an application emits that is specific to business, all those needs to be seen and somehow correlated to the worker type, activities, the workflows, and basically the entities that temporal service maps you to, right? So that's why,
Got
like,
it. Got it.
these things are very
So,
important.
so
Yeah.
much deeper correlation into different type of things, maybe doing more aggregations or creating alerts of things.
Yeah.
Because from what I understand, you can only do like filtering of workflows, etc., but you can't really take sort of any actions on it. Um, yeah. So yeah, I think would be great to see a demo of like what we have built. And I was looking at this before this call, and it really blew my mind, like what we have been able to achieve. So would love to see, like, have our audience look at this, and yeah, please
Right.
share.
Right. To be honest, I was also very much amazed by what we could achieve using OpenTelemetry native instrumentation. I had to go through a couple of changes to enable connect the temporal logger and OpenTelemetry logger, or your native or the logger, and kind of emitting those temporal metrics into an OpenTelemetry native format. So this is some non-trivial work that we did, and the dashboarding capabilities that we have that includes all the unified solution. It's a very interesting piece. Do you want me to give you a walkthrough of the code that Lattice sample application of Temporal has, or should I just go directly into the
Yeah,
demo?
maybe give some intro on like what the code looks like, and then we can go into the demo, like how you can monitor.
Sure. Sure. Let me share my screen and we'll dive into it. I hope you are able to see my screen.
Yes.
Awesome. So this is a very simple hello world example from the temporal applications, and this is also publicly available in our GitHub repo. We forked some code from the samples Golang from temporal repo, and we added a lot of instrumentation on top of it to make it work for observability and OpenTelemetry. Okay, so the hello world package has a connection which it uses to connect to the temporal service. The temporal service again is both a cloud option that you get as a pay for as you use, and then other it's a you can run an open source model also. The hello world file defines the workflow. So this workflow is just an example. You can have multiple workflows and try to connect multiple activities into a workflow. So activities are a temporal concept which you can relate to the steps in a workflow, right? So here, this workflow is a sample one, and it starts with, like, let me execute an activity. We call it an activity one. And then it sleeps for a random time between 1 to 3 seconds before calling the activity two. And then with a 50% chance, it calls activity three. Okay. And these activities are purely dummy data, and we just fetched the SigNoz.io URL into the activity one. And in activity two, we just slept for like 500 milliseconds, and then we printed activity two completed. activity 3 sleeps for like 750 milliseconds, and then we print like activity 3 completed. So there can be combinations of activities and their workflows. So there can be another workflow type 2, which can call activity number 7, 8, X, or whatever you call it. Feel free to name it. Okay. So this is the place of definition of activities and workflow. Okay. So the temporal application usually has two parts of it, where it has the starter or the client. This client usually, it's a very simple example that is only responsible for like giving a command to the temporal service that I want to execute this workflow. Okay, and we provided the name of the workflow here. That's all it does. So we are calling this workflow in loop, and there is a worker somewhere that executes a different part of the code whose responsibility is to run that code. And workflow, like we have already defined, these are the activities and these are the workflows. And in the worker, we register a workflow with a activity. Okay. That's all is basically the gist of how temporal works. It's a very simple one.
And if you want to scale workers, you create like multiple workers here, or
yeah,
it's like
it's as simple as like run multiple instances of workers and define your autoscaler policies to how to scale things up based on what metrics. So we added some instrumentation packages for metrics, OpenTelemetry setup, then tracing, intercepting, and your logging service. So all of these needs to get connected to the temporal internal framework somehow and emit OpenTelemetry native data along with the attributes that are important in the temporal world, like workflow type, activity type, namespace, task queue, workflow ID, and all these things. Right. Now, once you have done all of these, when you come to SigNoz's dashboard, you will see there are two services, the client one and the worker. And we get all the default APM stuff, the tracing, logs, and SDK metrics, everything at SigNoz in a single place. I will walk you through the different parts of it one by one. Okay. Yeah. So this is the list of services that you see, their average PNT and latencies, error rate, operations per second. You can go to the worker service and see what are the key operations that it executed. So running a workflow is in the boundary zone of a worker, right? And running these different activities is also part of worker, right? So you can see the red metrics.
Standard APM metric for the application.
Yeah. Right. So worker is an application eventually, right? So we get all the default APM stuff out of the box when we are done with the instrumentation.
Do we see anything in the external metrics or DB call metrics tab?
If you would instrument it, like if your application is using it, then probably you will get these. But our simple examples do not use any of this, except in activity 1, we are calling an external SigNoz.io. Okay. That is what we are seeing. So, and this is the response duration of SigNoz as observed from activity 1. Okay. So the more and more stuff we are doing inside an activity, all of them will be automatically captured by whatever the OpenTelemetry stuff provides.
Got it.
Okay. Then we'll go to traces to see, like, we'll have all of these traces and spans coming in from the activities and the workflow. I'll just click on one and show you. All right, so this is a temporal application emitting from the temporal client. So it all started from the client. We saw a missing span for a second or two, maybe because this was a very recent trace and the spans were still coming in. So once it came in, it automatically got shown here. So we have two services. It started from the temporal client with the stock workflow. Then it went to the temporal worker with the run workflow and the different activities. The activity 1 and activity 2. Okay, so we see the activity 2 takes around 450 milliseconds, and correspondingly the run workflow, the complete workflow, took 4.66 seconds to get complete.
Do we also get the latency, like the time the workers took?
Yeah, so this is the start of the workflow in that worker. Okay, and this workflow is executing to activity. So we have the latency of each activity along with the total time that running that workflow took.
And if there are two workers?
Yes, all of them will come here. Two workers and hundreds of activities, all of them will come here.
Interesting. I think that itself is pretty powerful to see all the workers working on a particular like client call and be able to see what's happening there.
Right. And correspondingly, we will have the attributes around the temporal ecosystem, like workflow ID, workflow type, task queue, namespace, activity type, and all.
And I'm assuming you can, all this attributes is available in the Trace Explorer to filter based on that. For example, if you just
Yes,
want,
yes, yes. We should be able to slice and dice and group by any of these activities. Okay.
yeah, maybe we can just check with one example, like filter for a particular worker or particular.
Okay. So let me just do service name equal to worker, and I'll group by workflow type. So I think it's a different name. The routine name was different. So it shows you clearly like there are three different activities running, and you can even count or even check the duration of these activities.
Interesting. So all the power of aggregation on attributes and like doing different type of filterings is available now to you over
Yes.
Temporal Workflow.
Yes, it simply shows the activity 2 is around 450 milliseconds and activity 3 is like 720 milliseconds and something near to what we configured in the code. Right?
Got it. Makes sense.
Right. And then we can come to logs to see like all of these JSON logs being emitted from the temporal application SDK, and we have different attributes like workflow ID, workflow type. Like these are very important attributes, because without these attributes, any understanding of things inside a temporal activity will become very difficult. Because if I have to debug, let's say I got a worker ID from somewhere and I want to debug or know all the logs from worker ID, then these attributes have to be present in the logs. Even using the logs, you can slice and dice on data because all of these are presented attributes.
Can you filter based on like messages, particular messages, etc.? That hey, this
Yes,
was
yes.
because I
Right,
saw
right.
you added some particular like specific text, etc.
Yeah, yeah. We can do that also. We have I think we are emitting some custom logs like activity started, activity completed. Okay, so let me check if we are having, yeah. So we have activity 2 started, and this is a custom log. And even that custom log has all of the attributes, including trace ID, run ID, attempt, which was an attempt number that this activity was successfully completed and started. Right.
And all these custom attribute, like all these attributes are being appended out of the box. Like user doesn't
Right.
need to add anything to like send the attribute.
No. So the instrumentation that we provided, if the user follows that, all of these will be out of the box. That is some great work that we did there.
And that's quite powerful because this is a pretty detailed instrumentation which you can get out of the box without doing anything.
Yeah, right. So even like we have even done correlations to the trace. I have added something in the pipelines that is going to map the trace ID to the hotel semantics of trace ID, and you can go to the trace directly from the logs and vice versa.
Nice. And this is possible because we leverage the OpenTelemetry trace ID. And then because SigNoz by default supports correlation across traces and logs, you're just getting this out of the box. You're not doing anything new. If you just instrument it in the right way and send data from there, attributes from there using OpenTelemetry specifications, you get all this out of the box.
Right. All of this is out of the box and pretty interesting to debug. Okay. So apart from, we went through traces, we went through logs, and then we will go to metrics to see like what we get in metrics. So first one that I will dive into is the temporal SDK metrics, which is like the temporal emits metrics in some format. And I put it into OpenTelemetry and send it to SigNoz. And this is like SDK metrics. It means it signifies what your application is perceiving in terms of latencies and metrics, right? So it is not that it is different from the temporal servers. What you see in the temporal server, and the application is the client one that communicates with the temporal server. So the worker slots usage, number of workers that were started, what is the execution latency of a workflow, what is the end-to-end latency of a workflow. Like our workflow that we have takes around 4 to 7 seconds, and it is moving around that.
So people can add alerts based on these latency charts, right? That hey, like I want to understand how much time is my temporal workflow taking, and if it is say crossing some limit which I usually see, I should get an alert.
Right. And from that alert, you can go to traces and logs and to start debugging more on based on that workflow ID or trace ID.
Interesting.
Got it. So these are some of the more stats that we can see, like which kinds of workflows are getting completed, what is the ratio, what is the temporal request latency as perceived from the application, what is the latency of the activities being perceived from the application, right? So yeah, so this is pretty much what the temporal SDK metrics emits by default. Like this is we are not doing a specific thing rather than converting the temporal metrics to OpenTelemetry native format. Okay.
And like from here, can you go to logs or traces?
Yeah, so I'll give you an example of a simple debugging use cases that I was trying to experiment with and see what good can be done there. So I built a custom dashboard that has the panels from metrics, traces, and logs from everywhere. The first few panels are the generic ones that I would like to know about my temporal states and all workflows and activities. Like I want to know which are the slow workflow executions happening and all of these things. And when I know about a specific workflow ID that I need to debug, I got it from somewhere. Either I saw it, I got it printed, I got it from the Explorer page. Then I'll just put that workflow ID here. As an example, I like listed all the spans and logs specific to that workflow ID. So this is a panel in SigNoz that you can use to list traces and logs. So interesting thing is like now you can see this is a span that was relevant to that workflow ID, and all these are the spans from that workflow ID. You click on it and you can go directly to the relevant trace where this span has originated
Very
from.
powerful. I think you can go from dashboards to the exact trace page or like the exact span page, and you can directly debug what's happening there.
Right. What's even more interesting, Pranay, is we can even go from logs to directly see the detailed view of the logs. Like here, whichever log line that you were interested in, and you can click on it, and a side drawer will come in showing you the logs detail page, and then you can even go to the trace ID from here.
And so we saw from like traces to logs, logs to traces. Can we go from like metrics, like the charts we see here?
Right, definitely. I'll give you a walkthrough of these things first, and I'll give you an example where like how we can transition from here to there, from one signal to another. One example of here is like the traces. We are printing the slowest ones, the slowest worker executions, and this is like the span name and the service name and the duration of that span. When I click on it, I can go to the trace ID. This is something we saw was similar to the below panels, like from the list view to the trace ID and logs details directly. We have even printed the same thing again, what we got in the metrics. Like we got the values from the traces. Okay, so this is the average latency of activities. And we again see it's like 700 milliseconds for activity 3, 450 milliseconds for activity 2, and 67 milliseconds for activity 1. Now, if you see some spike in any of the place and you want to go and check out which kind of traces were they, now you can click on it. You will get, like, you will have to click on the data point actually. And when you click on the data point, you click on view traces, it will take you to the traces explorer page with the service name, the activity type, which was the line chart that you clicked on, the time interval already filtered out, and you can see the list of spans there, and you can check out the trace ID directly.
Nice.
So this is pretty interesting according to me, and would help debug a lot of things much faster.
So these charts were built from traces, and that's why we can correlate from there to like the corresponding traces or logs. I'm assuming similar things you can do for logs. Like if you build charts from logs.
Right. We have an example here. Like, let me show you what we have in the query. So I gave an example like activity 2 to activity 3 happens only 50% of the times. And whenever we are not going to activity 3 from activity 2, we are printing a log that has a message called skipping activity 3. Okay. So using this, we are able to see the count of how many times is the activity 3 getting skipped in my workflow, right? So this is a chart where that basically helps you, and you can use many different custom messages or log messages or body from here. You can even use this to like plot how many times these specific kinds of errors you're seeing in your workers or things like that. Now coming to correlations, like once you have see this metric on this chart, you can click on this data points and you can go to logs. It automatically detects the data source that you have and the relevant attributes, and it takes you to the logs explorer page. So you can see these are the messages that contained skipping activity 3 during that time interval.
Got it. And this is possible because you're able to pass these data from the chart to the
Yeah,
to the log explorer page, right?
right. So what we'll do is we'll look into the data source and we'll look into the query where clause, and then we pass it along automatically to the explorer pages.
Interesting. And
Right?
like what's very interesting to see is that all this is built without doing anything specific for temporal, right? Like all
Right.
this is just the native capability of SigNoz's dashboard.
Yes.
And if you send SigNoz the right data points with the right attributes, like this is what you can do. So this is sort of also an example of what you can achieve through sending attributes across multiple signals, and then that will enable you to stitch from say metrics to logs, logs to tracer, and uh, essentially help you solve any issues which comes up very fast.
Right. So like this gives you shows you the real power of a unified observability tool which has all of metrics, traces, and logs, and gives you the ability to slice and dice on attributes of the logs and traces. So you can do these things and a lot more depending on the things that you debug in your real life.
Yeah, I think this is pretty powerful. Thanks for sharing the demo. So I think as we started saying that this is really, at least as far as I know, the most powerful observability for temporal, and I'm sure like the community members would love it. Hmm. What's next planned for this? Like, what are the next things which are building for this? Is it complete as a
Hmm.
feature, or what are you
Hmm.
thinking next for building in temporal observability? Because I know
Right.
there are many community users and many customers of SigNoz who are like actively into temporal ecosystem,
Yeah.
and they've been asking this from us for a long time.
Yeah. So that was the prime motivation to build this out. We definitely have sorted out a lot of things already with this version, and the docs are already live in our website under integration section. What we plan to do next is like we still need to fetch in the temporal server metrics. Like there's some server metrics or cloud metrics that temporal exposes, which is also useful to some extent to understand how the temporal server is doing, what is the server latency that they're seeing, right? So the next plan is to get those into SigNoz and like launch for more languages. Like today we have for TypeScript, Golang. I'd love to see things work out for Java also.
Got it, pretty cool. So this is like I think as far as I know today, temporal supports primarily Prometheus metrics by default, and this
Right.
would be the first sort of full-blown use case of OpenTelemetry powering temporal
Right.
observability, right?
So the difficulties that I faced with temporal documentation was that like their telemetry was fragmented. Some places they were saying to expose things in Prometheus format and use Prometheus to scrape them out. Traces were pretty much OpenTelemetry native. Logging was also a bit tough that you need to first like if you use a default logger in your application in your organization, you will need to connect the temporal logger to that your custom logger, and then either you write it out to a file to be exported to SigNoz, or you connect the OpenTelemetry bridge to send it out using the OpenTelemetry format. Bringing all of this thing together was took some time, and I would say it's quite uh, going to be very useful for the users. And it was not there out in the industry yet, so I had to pull up some time to make this work.
Nice. Yeah, I think this has come out pretty well. Kudos to you and your team for bringing this up, and yeah, hope our the community and our customers like it. Any last things you have to say to the audience and people who are listening to this?
Yeah, sure. So I'd love to hear feedbacks, and we'll be improving on this through. There might be some nuances at docs, like where you need to still figure out some stuff like versioning of your Golang or TypeScript, along with the versioning of SDKs of Temporal, which is still evolving, and even the SDKs of OpenTelemetry. If you face issues there, feel free to create issues or reach out to us on our Slack, and we'd love to make things work. Yeah, that's
Cool, Ankit. Thanks for joining in. And yeah, everybody, if you have any questions, feel free to reach out on a Slack community. It's signoz.io/Slack, or just create an issue or discussion in our GitHub community, and then would be happy to learn more and engage. Thanks
awesome.
a lot. Bye bye.
Bye. Thanks for having me.